Hey guys, in this video we're going to go over day 2 of Unit 9, which covers multiplying polynomials. The first thing we want to look at when we get started is to compare multiplying with adding and subtracting. Now when you add or subtract, you have to have like terms, meaning your variables have to match. So if we look at the first two examples, in the first one, we can add those two together because we have an x squared. That variable is going to stay the same, and we're going to combine our coefficients by adding. 5 plus 3 gives me 8, so I get a total of 8x squared. If our variables don't match, we don't have like terms and we can't combine them. So in example number 2, we have x to the 4th and x to the 5th. We can't put those together. They would just stay side by side. 2x to the 4th minus 7x to the 5th power. So we need like terms. We need the same variable. That variable is going to stay the same. It's not going to change. And then we add or subtract our coefficients. So only the coefficients change. When we move on to multiplying now, we don't need to have like terms in order to multiply them together. They can be like terms, but that's not required. So if I have 5x squared times 3x squared, I like to start by multiplying our coefficients. So I'm going to take 5 times 3 to give me 15. And then I usually multiply the variables next. X squared times x squared. Now, keeping your properties of exponents in mind, if you multiply these two expressions together, you combine them by adding their powers, their exponents. So 2 plus 2 gives me a total of 4. So this would equal 15x to the 4th power. I'm going to do the same thing in this last example. Notice now that my variables are not like terms, and that's okay. I can still multiply them together. I just can't add or subtract them. So starting with your coefficients, 2 times 7 gives me 14. And then I have x to the 4th power times x to the 5th power. If I add 4 plus 5, I get a total of 9. So this is going to be 14x to the 9th power. So again, unlike adding and subtracting, when we multiply, we don't need the same variable. We don't need like terms. And that variable, when we multiply, will change. We multiply both the coefficient and the variables. We've actually done some multiplying polynomials with quadratics. You just might not have called them polynomials. So when we are multiplying together, we're putting those into standard form from factored form. So multiplying takes our factored form and turns it into standard form where our two factors are getting multiplied together. So that would include processes like distributing, and it would include foiling. All right, so we're going to start with distributing. We can distribute other polynomials that are not quadratics. So in this first example, I have 3x getting multiplied by this long polynomial in parentheses, and I need to distribute that 3x to every term in that polynomial. When I do that, I'm going to keep in mind my properties of exponents that tell me if I multiply two variables together, I combine them by adding their exponents. So starting with 3x times 5x to the 4th power. I like to do the coefficients first. 3 times 5 gives me 15. And then I like to look at my variables, x times x to the 4th power. Although we don't see it, this x does have an exponent of 1. So when I combine that, I need to add 1 plus 4, giving me a total of 5. So I have 15x to the 5th power. I'm going to repeat that process 3 more times. Next up, I'm multiplying 3x times negative 3x squared. First my coefficients, 3 times negative 3 gives me negative 9. X to the first power times x squared gives me x cubed. Halfway, round 3, I have 3x times 4x. 3 times 4 gives me a positive 12. X to the first power times another x to the first power gives me a total of x squared. Last round, 3x times negative 7. 3 times negative 7 is negative 21. I don't have an x here. You can write in x to the 0th power if that's helpful to you. X times x to the 0th power is just x, or x to the first power. Always important to double check that there are no like terms to combine or simplify. I don't see any here, so my final answer is this new polynomial. We can FOIL other non-polynomials too. If I have two binomials, which means we have two terms in each parentheses getting multiplied together, I can use the FOIL method to organize my multiplication. Right? When I do FOILing, I like to write it out as a list so that I remember the 4 parts of FOIL, starting with F, which stands for firsts. I'm multiplying the first element of each parentheses together, of each factor together. 3x squared times 7x. 3 times 7 is 21. I have x squared times x. 2 plus 1 is 3, so my first terms multiplied together simplify to 21x cubed. O is for outsides. My outside values are 3x squared and negative 2. 3 times negative 2 is negative 6, and I don't have any other variables to combine, so I get negative 6x squared. Next up is the I, the insides. 4 times 7x. 4 times 7 is 28, so I get 28x. And then lasts the L, 4 times negative 2 gives me negative 8. Okay, if you do it in this kind of structure of writing them out as a list, you have to remember to combine them by adding all of those terms together into a single polynomial. So my final answer would be 21x cubed minus 6x squared plus 28x minus 8. Our last two examples are going to be multiplying polynomials that have more than 2 terms. So more than we would have with the FOIL method. And I'll show 2 different ways that you can organize this multiplication. The first method is what I call the double distribution method. In my first polynomial, we have 2 terms, x plus 3. So I'm first going to distribute the x into the second factor, and then I'm going to distribute the 3 into that second factor. So I'm going to start with the x. I'm going to take the x and multiply it by everything in that second parentheses, starting with x squared. X times x squared gives me x cubed. Next I have x times negative 4x. That's going to give me negative 4x squared. And lastly, x times 6 gives me a positive 6x. I have a second round of distribution to go. Now I get to take that 3 and multiply it into everything in the second parentheses. 3 times x gives me 3x squared. 3 times negative 4x gives me a negative 12x. And then 3 times 6 gives me 18. Before I can circle this as my answer, I have to combine any like terms. And the bigger your polynomials are that you're multiplying, the more likely there are to be like terms. So I see some x squareds, negative 4x squared and positive 3x squared. I'm going to have to combine those. And then I also see some x's, 6x and negative 12x, that I'll have to combine. When I write this in standard form, I'm going to go from greatest exponent two smallest exponents. So I'm starting with my x cubed. There is nothing to combine with that, so that stays x cubed. Now in my x squared position, we have -4 and a +3, giving me a total of -1 x squared. Next up, we have +6x minus 12x, total of -6x. And then my constants at the end, 18. All right, this last one that we're going to see is the most complicated. It has 3 terms in each polynomial getting multiplied together. I'm going to show you another option for how you can organize this multiplication other than the distribution method. So this last one I'm going to do through what is called the box method. And I'm going to start by drawing a big box. Then I'm going to divide the box up into 3 columns and 3 rows. Across the top of the box, I'm going to put the 3 terms of my first factor, my first polynomial, 6x squared, -6x, and -5. Across the right edge of my box, I'm going to write the 3 terms of my second factor, that second parentheses, 7x squared, 6x, and -5. Now I'm going to fill in the middle of my box. I have 9 spots to fill in, and in each spot I'm going to fill it in by multiplying the values on the outside. So for this upper left-hand box in my box, I'm going to multiply 6x squared times 7x squared. 6 times 7 is 42. X squared times x squared is x to the 4th. I'm going to continue to fill in these other squares within my box by multiplying the outsides. So in the top middle, I'm going to take 7x squared times -6x. 7 times -6 is -42. X times x squared is x cubed. I'm going to continue to make my way across that top row, taking 7x squared times -5. -5 times 7 is -35. So I get -35x squared. I'm going to do the same thing in these next 2 rows. I got 6 more. 6x times 6x squared is going to be 36x cubed. In the middle, I have 6x times -6x, which gives me -36x squared. And then in that last section, we have 6x times -5, giving me -30x. We're over halfway, just a couple more to go. In the bottom row, starting with -5 times 6x squared, giving me -30x squared. Bottom middle, we're going to have -5 times -6x. Negative times a negative is a positive, so I get +30x. And then lastly, we have -5 times -5, giving me a total of +25. Okay, I have 9 terms here that I need to combine, and I've kind of already color-coded them, but you will notice that your like terms show up diagonally. So my x cubed, you can see, are kind of kitty corner from one another. Same thing with my x squared. They go across the center, and then my x's. So in the box method, you can kind of simplify as you go. So starting with the top left, right, we have 42x to the 4th power. No like terms to combine it with. For my x cubed, I have a +36x cubed minus 42x cubed, giving me -6x cubed. For my x squared, we have -30 negative 36 and negative 35. If you add those all together, you get a negative 101x squared. 30x minus 30x is going to simplify to 0, so I'm going to leave that off. Those are going to 0 out. My last term is going to be that plus 25. Okay, so my final polynomial there is at the bottom.